Computer chips are the brains of smartphones, digital media players, and all other modern consumer electronics. They're also the lifeblood of modern society. Life as we know it could not exist without them. Chips are small electronic circuits, or integrated circuits, that contain the transistors and other tiny components needed to process electronic data signals. Small, inexpensive, reliable, and easy to manufacture, they became popular late in the 20th century. Those early computer chips, wafers of silicon about the size of a postage stamp, could hold about 2,200 transistors. Today's chips, on the other hand, may contain 1 billion transistors, and they're light years more powerful. These advances were possible because scientists discovered new materials and processes for packing electronic components closer together on chips, and for wiring connections between the components. Meet one of those pioneers. Robert Miller, winner of the 2010 American Chemical Society Award for Chemistry of Materials. As a chemist at IBM, Miller developed materials that helped pack more transistors onto each chip, paving the way for the electronic products that make everyday life longer, healthier, happier, and more enjoyable. Here's Dr. Miller.
One of my first efforts within IBM was the development of new materials to make finer lines on chips, which became finer wires, which allowed you to make higher and higher device densities on chips of a relatively small size. The spin-off on that was as chips became smaller and the device density was higher, they began to actually run slower and hotter, and this required new materials separating those wires, new insulating materials.
Besides helping IBM shrink the wiring on chips, Miller and colleagues spearheaded development of porous insulators, materials riddled with millions of tiny holes that allowed chips to run faster while consuming less power and producing less heat. The microchip continues to get smaller and more powerful every day, which will require still newer materials.
When I first started looking at it, there were like 10 elements that were used in chip manufacturing, okay, 10 elements. I counted them the other day and there are 63 that have been used. They're not all used all the time, but they have been auditioned in some fashion or another. So new materials have really enabled the continual scaling. The biggest challenges in the future is to maintain exposure tools that can produce very, very small patterns, and to keep materials that enable you to utilize those small patterns in a productive fashion.
Dr. Miller and hundreds of other scientists are already working on tomorrow's chips, which may be so small that about 50,000 of them could fit across the width of a single human hair. These nanochips will foster revolutionary new smartphones, portable digital media players, and products that we, and even scientists like Robert Miller, couldn't even imagine.